The geometry of thatched roofs, designed for rain and heat. Do you know that across Africa, from the Sahel to the Zambezi, millions of homes are protected not by steel or concrete, but by geometry? A simple bundle of grass, when arranged at just the right angle, becomes a high-performance shield against rain, heat, and wind. This is not primitive craft, it is applied geometry, climate physics, and material science perfected over centuries. It is not the straw that keeps the rain out, it is the angle. It is not the palm leaves that cool the house, it is the air cavity and convective flow they enable. The real secret of thatch lies in geometry, that is the slope, curvature, overlap, and airflow. African builders mastered this long before fluid dynamics had a name. The conical roofs of the Zulu Rondavel, the Fulani hut, and the Hausa gable are pure geometric logic. Rain in the tropics falls hard, so the roof must be steep. Hot air rises, so the roof must breathe. The cone does both, it throws off torrents of rain instantly and creates a rising spiral of air that cools the interior like a natural chimney. No electricity, no steel, just geometry and intelligence encoded in craft. Here is the math equation of rain. The pitch that protects at 30 degrees, rain lingers. At 45 degrees, it runs. Above 55 degrees, it flies off. That's why African thatch roofs are rarely flat. They rise sharp, slicing rain before it can soak in. Each layer overlaps like scales on a fish, not to stop water by force, but to redirect its path using the physics of flow and gravity. That is structural hydrology taught not in textbooks but in tradition. When sunlight hits a thatched roof, something extraordinary happens. The porous grass traps cool air that is a thermal insulator. Hot air rises into the upper cavity, a convective buffer. As night falls, trapped moisture evaporates, a self-regulating thermal cycle. While modern cities fight heat with AC, Africa's indigenous builders solved it with ventilation geometry and porous physics. Every stitch, every knot, every ridge cap has a geometric purpose. Eaves are extended to control splashback. Ridges are domed to prevent capillary wicking. Even the stitching pattern, spiral or stepped controls how quickly water runs. These are mathematical codes disguised as craft, tuned by generations of empirical engineers. Africa's diversity shaped unique solutions. In Nigeria's Middle Belt, builders mix palm fronds and Guinea grass for dual layer protection. In Botswana, they braid thatch to resist desert winds. In Uganda, thatchers angle the apex slightly open, a vent that also let cooking smoke escape. Each design is a localized response to wind, rain, and heat, a proof that climate architecture was born here. Today, architects are rediscovering thatch not as nostalgia, but as bioengineered performance material. Digital models now simulate airflow, slope efficiency, and drainage patterns inspired by African forms. Combine this with treated fibers and waterproof membranes, and you get a hybrid roof. Ancient geometry, modern precision. The future of green architecture may just rest on Africa's oldest design code. A thatched roof doesn't rot, it breathes. Its secret is self-drying geometry. Air circulation through porous layers evaporates trapped moisture. That's why a well-made African thatch can last 30 years or more. When repair is needed, builders replace just one radial sector. Modular geometry, centuries before modular design became a buzzword. So next time you see a thatched roof, look again. You are seeing a mathematical structure, an environmental algorithm, and a story of adaptation. Africa's thatched roofs are not relics, they are proof that sustainability isn't new. It was discovered long ago in the rhythm of rain, the flow of air, and the wisdom of hands that knew geometry before equations existed. This is the geometry of thatched roofs, Africa's design for rain and heat. From the roots of Africa's architecture to the frontiers of climate design, discover the physics of tradition. If you enjoyed this deep dive into indigenous innovation, hit subscribe.